struggling, and Wendy said, no, not yet. And we were like, okay. And then Wendy said, okay. And we all looked at each other and went, B squared equals C squared. And said, right, we're done. Okay. Different ways of doing it. Steve started explaining number 1, and we all looked at number 2 and said, yeah, that makes sense. We all ignored number 3 because it looked really complicated. We didn't really take much notice of 4, and then we said, well, yeah, we can understand number 5 because we know about the squares, but they just put extra lines in. So what we decided to do was to tackle one of the questions, one of the proofs each. And very bravely, good man, decided to have a look at number 3, the tessellation, and you looked at number 2, didn't you? And I started looking at number 3 and sort of gave up, to be honest. So what we decided eventually to do was to run with Adam's idea, which is strange because that's the one that we thought was the most complicated and confusing, and we were actually trying to avoid it. But that is what we've done. So we've taken A, which is one large square here and a smaller one here. The area of this, the scale factor from this small square to the big square is 2, which I can show you that these 4 of these above it. So we can see that 4 of these small squares will fit into this larger square here. We then proceeded to what? Adam proceeded to test by using the template that he made. And then started.
So first of all, we can tessellate the shapes like it is on the sheet. Now I originally thought, well, I don't want to copy that, I'll do it a different way. Then we'll go back to the same one. So after we tessellated the shape, we thought, well, we need to make our right angle triangle. So first one we can see is downhill. If you go down there, you can make several right angle triangles. So we used, so you've got your right angle triangle. What to use that? So C squared, we said should equal A squared, which is nicely drawn already for us, and B squared. We assumed this was B squared. We said, well, it looks right, if we move it up, that would be B squared. From there, then C squared, if you can see it, is split into sections, which, when you break them down, there is 4 different areas. Wait, spot on that, near enough. C squared's actually got 4 different shapes in it, so we said somehow these 4 shapes have to fit into there. You bisect them and move them around, should equal A squared and B squared.
So, sort of played around with it, and we thought the best way to do that was to label a little bit of manipulation we saw. Yep. So I've taken shape 1, 2 and 3, writing ones down. Everyone's satisfied that those shapes are. Yep. But unfortunately we're left with this one remaining triangle. Right, so shape 4 is left, we did nothing with shape 4. But right, let's now consider that. What we're trying to show is that shape 4 can be shown as A squared. Some people might be able to see that straight away then. Then we thought, how can we split shape 4 up? Well, dissects quite nicely.
So we've got the original, like what we said is if you just extend this line,
yes,
dissect it.
How's your dissect it? And then we come around here, just try to show what that does.
And the plenary for the lesson is how many different ways can you tessellate the shape, and we'll leave that with you. For the lesson is how many different ways can you tessellate the shape, and we'll leave that with you.